Right. We're going to ease you into word problems. So again, what we're doing today, we're going to take and combine with what we did yesterday in a big problem. So in the real world, linear programming is used all the time. Okay? Jobs that work with production and profit use linear programming on a large scale every day. My fiance works in the fraud department at Huntington, and they use linear programming all the time. It is used. He's used it in previous jobs before as well. We're not lying. People use this stuff. Okay? And this is just to ensure that their company makes the most money they can and is most effective in creating the product. Okay? What we're going to do today is learn how to write equations from these word problems. Okay? If we look at the first example, you can boot up, of course. There you go. Supermax Incorporated manufactures two different types of wood baseball bats: the Homer Hitter and the Big Timber. Okay? The Homer Hitter takes 8 hours to trim and turn on the lathe and 2 hours to finish. Each Homer Hitter sold makes a profit of $17. The Big Timber takes 5 hours to trim and turn on the lathe and 5 hours to finish, and its profit is $29. The total time available for trimming and lathing is 80 hours. The total available time for finishing is 50 hours. Oh my gosh, that is a lot. Okay? Well, there's some tricks you can do to kind of help you organize this information. Your first step when you're given a problem like this is to identify your variables. I just like to use X and Y. Because what we'll do tomorrow when solving, if we use different variables, it can get confusing. Of I don't know which one is X, or I don't know which one's Y. Just use X and Y. X, Y. To figure out which things in your problem are representing variables, it's the products you're making, the products you're selling. What two products are we making and selling? Homer Hitter, let's make that X. Okay? What's the other product we're making? Little hint, the products. The two things you're making or selling. Okay? Always going to be your variables. Okay? This thing, that's your first step. Figure out your variables. Your second step, write the objective quantity equation. Oh my gosh, lots of big words. Okay? It's literally an equation that's representing the profit. Okay? Really easy equation to make. You're just using that f of x, y equation, and you just look back at your information. How much do they make off a Homer Hitter? $17. So you just do 17x because x is representing the Homer Hitter. Plus, how much money did they make off of Big Timber? 29. So we would just say 29 y. Done. There's your equation. Because you're taking what you make per Homer Hitter, and you're taking what you're making per Big Timber, and you're adding them together. That's how you figure out your profit. Done. There's your equation. It's literally just taking how much you make off the one item plus how much you make off the other item, and you make sure the correct variables are written next to those prices. Done. Questions over how we got there? Here comes the tricky part, and it's okay. Write the system of inequalities that describes the constraints. Okay? I really like to make a table, and you set up your table the same way every time. So you're going to make 3 lines, like so. And then a big line across the top. Okay? The 2 middle ones are always your variables. So one of our variables was the Homer Hitter. I'm just going to call it Homer. And the other one's the Big Timber. I'm just going to call it Timber. So your variables always go in the middle 2 columns. Always your variables. Every time. Okay? This last one is always total. And this first one's always constraints. Every time. That's how you fill it. Constraints, your variables, total. Every time. Okay? Your constraints are what's limiting you. So then you have to go back into your word problem and figure that out. What is kind of limiting your production? So if you're kind of reading through what's just giving you a limit that you just can't work hours on in and make as many things as you want to make. Yeah, the hours. Hours to do what? To trim is one thing. You can't trim forever. There's a limit on the hours you can trim. Okay? What else? Yeah, trim, those two go hand in hand.
Okay, then.
Finish. There's also a limit on the number of hours it takes to finish. Okay? Those are your constraints. If we look, how many hours does it take to trim a homer hitter? 8. So that's what you're filling in here. 8. How many hours does it take to finish? Or sorry, to trim a timber? 5. That goes there. How many total hours do you have for trimming?
Yeah,
80 hours. Done. Right? Hold that part. Do the same thing for finishing. If you look back at the word problem, how many total hours does it take to finish a homer? 2. How many hours for a timber? 5. How many total finishing hours do you have? 50. You literally just made your equations. That's the reason why. What variable did we represent with homer? What variable did we represent with timber? You add them together all the time. Here's the thing. We're writing the inequality. We only have a total of 80 hours. So can we go over 80? No. So the amount of hours you have to make these has to be less than or equal to 80. Can't go over 80. That's our maximum. So it's always going to be less than or equal to. You repeat the same thing here. X represents homer. Y represents timber. You add them together. We can't go over 50 hours. So that all has to be less than or equal to 50. Your equations are made. Write them outside of your grid though so I can see them. Because sometimes I have different colors, but when you put a plus sign over that line in pencil, it's really hard to see. That one's made. That's done. Tomorrow we'll go into nope, we just want those. Questions. It's the same process every time. You're just dealing with different information. Okay. So questions, flip it over. For example 2, it says an automobile manufacturer makes cars and trucks in a factory that is divided up into 2 different shops. Okay. The first shop, which does the basic assembly, needs 5 worker days per truck and 2 worker days per car. The second shop, which does finishing touches, needs 3 worker days for both cars and trucks, for both of them. The first shop has 180 worker days available per week, and the second shop has 135 worker days available. The profit per car is $500, and the profit per truck is $700. Very first step, what are your variables? AKA, what are our 2 products? Think products, an item you're selling. We'll get into, yeah, trucks and cars. Good. We'll get into what you just said here in a second. So I always like to use X and Y. I'm going to say X is cars, Y truck. Some of you are like, oh, but C and T make more sense. It gets confusing when you graph. So when we graph, we like to do with X and Y. Okay? Find our variable. Now we have to write that objective quantity equation, aka an equation for our profit. F of X, Y all the time. Always do that. How much do we profit from a car? So how would that look like in our equation? Yeah, 500x. Plus, how much do we profit from a truck? 700. So what would that look like in our equation? 700y. There you go. You just made that. Just take the profit of the one object, write it next to its variable, add it to the profit of the other object, write it next to its variable. Done. Major profit equation. Okay. Now we have to write that system of inequalities. Okay? Make your table. What did we say the two middle ones were always? Yeah, X and Y, your variables. So your two products. So we're going to say car and truck. If it helps, you write the variable above it. We said car was X, truck was Y. What does we say always goes in this first spot? Constraints. And what always goes in the last spot? Total. Make your first. Now back to you, Megan. What would be one of our constraints? What's the limit between us? Yeah, basic assembly. We'll just call it assembly. What's another thing that's limiting us? Basic assembly, finishing touches. Keeping us from doing whatever we want. Okay? Restricting us. Alright, well, how much assembly time does a car take? Yep, 2 per car. Alright, how many for a truck? How many worker days? 5. And how many total assembly? You have to be careful, assembly happens in which shop? The first shop. So how many worker days does shop 1 have? 1 each. How many total do we have for a car for finishing? 3. And 3. We need 3 for both. How many total worker days do we have for finishing? 135. Because again, finishing is happening in shop 2. Shop 2 only has 135. You just made your equation. Again, we add here. Fill in your variables. What's our sign going to be? Is it going to be greater than or equal to or less than or equal to? Or both, because we can't go over those amounts. You can't go over, and it has to be less than or equal to.
Is it normally less than?
Yes, like 90% of the time, it will be less than or equal to. We'll get into one where it happens to be greater than or equal to, and that means a minimum amount. Can't go under. Right now we're talking about maximum. And then again, make sure you write your equations out of the box so I can see them nice and clearly. Sometimes it's hard to tell with pencil. And you're going to have to write them out eventually when we solve these. Okay, questions over that? No? Okay, we got one more. Here's a teensy bit different. But same process. Stitches Incorporated can make at most 30 jean jackets and 20 leather jackets in a week. It takes a worker 10 hours to make a jean jacket and 20 hours to make a leather jacket. The total number of hours by all of the employees can be no more than 500 hours per week. The profit on a jean jacket is $20 and the profit on a leather jacket is $50. Again, very first step to find our variables Taylor. What are our variables going to be? If we have x and y, what do we want x to represent? Good. Jean jacket, so that means Taylor y is going to be what? Good. A few products. What we're selling and making. Write the adjusted quantity equation. When we say that, we're really just talking about what? Yeah, that's what section 1 was talking about profit. Alright, so what's that going to look like? Kennedy?
20x plus 50y.
Good. 20x plus 50y. We have $20 per jean jacket, so 20x, because x is representing jean jacket. $50 per leather jacket, so it's going to be 50y, because y is representing leather jacket. Anyone have questions over that part? Look at that equation. Megan?
Aren't jean jackets 30?
Huh?
20?
Careful, that's the amount that you make. Profit, talk about money. So that's a good question. That brings up, always look for, when saying profit, look for dollar signs. That's going to help.
So where does the hours come in? Is that where it's like in C? Is that what happens?
Yep, that's where the hours, because that's your constraint. You can only have so many hours to make things. So now we have to write those inequalities. Again, what's going to go in the two middle ones? Other Z. Your variables, your two products go in the middle. What's always here in the first one? Strengths. Good. And what's always the last one? Now spell it right this time. There we go. Ink your lines. What's limiting us? Hours. Yep. This is where it's a little different. What else is limiting us? Can I make 1,000 jean jackets? Can I make 500 leather jackets?
It's like per one.
Yeah. Why can't I make those? It tells you in the very first sentence. How many jean jackets are you allowed to make? Oh, you can only make 30 jean jackets in a week. You can only make 20 leather jackets in a week. That's limiting you, because what if I want to make 500 jean jackets in a week? I can't. It's constraining you. It's keeping you from making a certain amount. So that's going to be one of them.
Can we just take jackets for
Number of jean jackets.
How do we do that
You
for
can
the leather?
say, yep, nope, yep, it'd be individual. So the number of jean jackets and number of leather jackets. This is where it's a little different. We'll see here in a second. Because there's a limit on the number of jean jackets you can make, and there's a limit on the number of leather jackets you can make, so they're separate. Okay? So we go through filling our table. How many hours do we have for a jean jacket? Look back at the word problem. 10. How many hours for a leather jacket? 20. And how many total hours do we get? 500. Okay? We're only making one type of jean jacket, right? How many total are we allowed to make? 30 in a week. We're only making one type of leather jacket. How many total are we allowed to make in a week? 20. These guys are zeros. A leather jacket is not a jean jacket, that's 0. A jean jacket is not a leather jacket, that's 0. Why it has to be separate. Really tempting because you're talking about amounts to say, oh, 30 and 20, but is there a total amount? No, so that's why they have to be separate, because the 30 and the 20s are your total. Okay? That's the trickier part. That's okay. I'll form out this one. Now you just make your equations. Jean jackets X, leather jackets Y. Add them together. What's the sign going to be? Less than or equal to. X plus 0 less than or equal to. We can't go over 30. 0 plus Y less than or equal to. Can't go over 20. Write them outside your box. So this guy's 10x plus 20y less than or equal to 500. X plus 0 is just what? X. We just say x is less than or equal to 30. 0 plus y is just what? So we just say y is less than or equal to 20. This is kind of a trickier one because you have to realize there's a limit on the amount of one thing and a limit on the amount of another. So you have to make sure they're separate. And you'll realize if you try to do it as one big thing, you'll have 20 plus 30 with no total. If that happens, then you know they need to be separate. Okay? Questions?